Now, having said that, I'd like to talk about error messages because that's something that I swept under the carpet up until now. The reason why, one of the reasons why people don't like putting validation code in the database and relying on that validation code is because it's so darn difficult to get good error messages back to the user. What happens when those validations fail is that you get an exception is thrown in your Java code, and it will probably give you a SQL code, and it may give you some text, and you could actually go and parse that and look that up in tables, etc. But it's a nightmare to do that. That's why people don't like doing that. Now, in fact, if you have this validation at a too extreme, the issue doesn't arise because since you're doing validation, since you're doing exhaustive validation against stupidity of the user in your browser, you can do your error handling there. You can give excellent feedback on what the user is doing wrong there. And if it happens that something is rejected at the database level, then there are two possible reasons for this. One is that there is a bug and you should fix it because, well, basically you've missed a case, or an attack is going on. And if the latter is the case, the last thing you want to do is to give an error message back. You may want to do other things. You may want to raise an alarm or shut down the system even, but you don't want to give an error message back. So, yeah.
It seems like there's some, where would you do your authorization and validation? Would you do those at the database layer as well? Because it seems like those routines might have to act on the data. And if the data's not good, you could cause those things.
I would like to do authorization at the database level, yes, but in most shops that would have such a high impact to do that it would not be feasible.
It seems like that assumes, in many cases, good data, or you're trusting the data in some way, and there's other intermediate processing other than authorization and validation that you might be doing in between the two extremes.
Sure.
That assume good data.
Yeah.
Yeah. So how would you handle that case in this? And if you want to wait on that, we can.
Yeah. I'd like to take that offline because
Okay.
that's actually a huge topic.
Okay.
Yeah.
How does that work for one firm where the architects declared that access to the database or update of any kind of update needed to be done with stored procedures?
Right.
And that all view access, read access should be done through views.
Right.
So, I mean, I guess that seems consistent, although
I sympathize entirely with that view. Yeah. Okay. So let me examine the drive principle again. So we've got rid of an awful lot of duplication. We just got rid of all that code that was sitting in between that wasn't really serving us terribly well. But unfortunately, there is still an overlap between the validation on the browser and the validation on the database level. And to be honest, I can't quite see a good way of getting rid of that. So let's just reflect on that. First thing I would like to say, there is nothing wrong with checking something twice. That's not actually against the drive principle. The drive principle is about code duplication. It's not about runtime duplication. If the same code gets invoked multiple times that's not going to cause you any maintenance upsets. Now, having said that, our code does express the same test, the same validation twice, once in JavaScript and once in SQL, and I can't quite see a way of getting rid of that. Now, as a consolation, I can say, well, you know, if you express the same integrity constraint in several formalisms, and that's, after all, the reason why we still have that that duplication, because we're forced to express it in two different formalisms. But an argument could be, you could make an argument for saying at development time, it helps you covering the whole range of validation that needs to be done by expressing it in different formalisms. So that can bring you some advantages. I'm not entirely convinced by that argument, and I would like to see a technology stack where a single source can be distributed over several tiers. I was going to look at some possible candidates that sort of think along those lines, but I'm running out of time. The essence of the thing is that Ruby on Rails basically relies on code generation in order to allow you to express everything in quotes in Ruby. At the end of the day, although it's true that you can express it all in Ruby, you can't do the validation actually in the database, and you can't do the validation actually in JavaScript in the browser as we would wish to. GWT goes a little bit further in the sense that it compiles Java to JavaScript if it's executed on the client side, and so the same code can be both run on the server and on the client. So you have the same code running on different tiers. But you can't do your validation in the database there either. To conclude, I think it's important to make a clear distinction between two things. You want to protect against two different things. One is what I called malice, and the other is what I call incompetence. To mix them up is going to make you end up with less than ideal code. My advice would be to protect against malice at the very last possible moment, and to protect against incompetence at the very earliest possible moment. And of course, if you do take something away from this talk, remember that it's important to keep dry. So, are there any further questions or comments? Yes, please.